Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi class, welcome back. So now we're going to discuss on experiment 3, which talks about the chemical kinetics. So the objective of this experiment is to determine the rate constant of the hydrolysis of methyl acetate. So this video gives you a good feel of how the experiment is being conducted, and this experiment also shares some of the tips and what the experiment is all about. So the whole procedure is not only in this video, it's me myself in the video. So I also shared on what the experiment is about and how it's conducted, and also on certain, the basis of why you're doing this and that. So make sure that you actually watch the video so they have a good feel of what this experiment is about, and also you can appreciate the data that you obtain. So the hydrolysis of methyl acetate. So this is methyl acetate with water. Okay, will give you acetic acid and methyl alcohol. Now, this reaction happens to be a first order, although it looks like it's a second order reaction because you have two molecules involved. You have methyl acetate and water reacting to this. Now, why is this a first order reaction but not a second order reaction? Is something that I want you to also discuss in your lab report. Okay, let me repeat that. Please discuss why this is a first order, not a second order reaction. As in, this is quite a popular experiment. So I want you to do a little bit research on why this is so. All right. You get this data sheet, which is given to you. And so because you're doing the experiment in the water bath, as I said, please watch the video. Okay, so one of the importance of doing the experiment is to ensure that the temperature of the water bath is constant. So every 15 minutes you want to check that's constant. So you have a thermometer that you actually immerse in the bath, although there is a digital thermometer in the on the thermal regulator, but this is more accurate by using this thermometer. So you just want to make sure that it's constant, and most of the time it is. Okay, we just want to make sure, because if it's not constant, so you get this, your results is not going to be consistent. Okay, so then with that you also have this at a certain time interval. So you have to do something, as you've seen in the video. So you have to take out solution from the water bath, and then you do the what you call the titration, and so on and so forth. But we talk about that in a little bit. So with this, as I said, the data sheet is only given in your first year, but at least you can appreciate how you should actually tabulate your data. Okay, and at the end of the day, what you need to do is actually plot the value of this against time, and what you get is from that value you can actually find the rate constant of the reaction. Okay, so so perhaps it is in red to actually highlight something, but the materials used as such. But you have methyl acetate, you have, and in the video you will see the setup. You have the methyl acetate, you have the HCl, and HCl actually acts as a catalyst, and you use NaOH and phenolphthalein. This is for your titration process. So you transfer 100 ml of 0.5 molar of HCl into a conical flask, and you put a stopper and place the flask in a water bath, and then you also add methyl acetate in the same water bath. So you have two conical flasks sitting right next to each other, And while the temperature of these chemicals equilibrates, so you can start preparing, filling up your burette with the NaOH. Now this is going to be a wet experiment where you need to use ice to stop the reaction. So while the temperature equilibrates, you prepare that, and then you want to, as I said, you want to make sure that the temperature of the water bath is constant throughout the experiment. Okay, so once you feel that the chemicals in the equilibrium, has reached equilibrium, and usually you use that by checking the temperature. So now you pipette 5 ml of methyl acetate into the HCl. So once you do that, that means you have started the reaction. Okay, and I also talk about the timing, so you can look at that video. So once you have added the the methyl acetate into the acid, so the reaction has already started. So now you know that that reaction will give you alcohol and acid, right? Acetic acid and alcohol. So when you do the titration, you're actually titrating, you're using base. So the amount of acid that is being produced, and as time goes on, the amount of acid produced increases. So you can expect the amount of NaOH used also increases. So you want to actually record, record the temperature, the amount of acetic acid produced at particular time. So that's when you use the ice to actually, it's not really icy water, you want it to be, because icy water is not cold enough, you want that ice, okay, and you to stop the reactions. But of course there will be some inaccuracy in there. It may not really be stopping because it's not cold enough. So timing is also important, as in the video I also mentioned. So it says here 10, 20, 30 minutes, but if the timer says that it's 10.35, so jot down the exact value 10.35, and usually students miss on that, so they just take this 10, 20, 30 as it is on this table. This table is just there as a guidance, okay? It doesn't mean that you have to follow the timing here. You follow according to what the timer actually says. If it says 10.21, 10.1, 20.15, 20.5, so you actually record the exact time, which is which is accurate. Then you just take that 10, 20, 30, 45, 60, and 80. So you just follow the same procedure as you will see in that video, okay? And every time you take another set, so you can wash whatever the first iteration, and then you wash, you wait until the 20th minute, and then you start again, pipette out the 5 ml of the mixture, and you make sure that you add ice first, okay, and the phenolphthalein, and then the mixture, and then you titrate. So you do that until the 80th minute, okay? So you have the remaining mixture in a conical flask. So what you need to do is to heat that for about, until it boils completely, and then once it has already cooled down, you titrate the solution twice so that you get the average, okay? So the difference that you actually get is proportional to the concentration of the unhydrolyzed ester, and so the VT is the volume of NaOH required in titration. That's reacted in time t. Okay, and this V infinity is the volume of NaOH required for the mixture that has completed. So with that, you take the plot of V infinity, ln of V infinity minus Vt versus that of t, and you get a straight line with a gradient of negative k. So because this is a straight line, you can use the y equals to m mx plus c equation to actually find the necessary values. And in this case, for this experiment, you want to find the value of the rate constant of this reaction. So once you get the rate constant, you can also use that to find the half-life as what is requested in the lab manual. Okay, so you can get these two values, the rate constant and also the half-life, and you discuss on this experiment. Okay, so this is an example data that we have. So this is data by students. So this particular student measured the temperature of the water bath. As you can see, that it's constant at 30 degrees, so that's good. So they did the burette reading, so you can see here. So this is already calculated. You may want to double check on the calculation. So somehow I think because up to the end of the titration, it's I think they had to refill the burette so that they get to actually the endpoint. So, but the total value of V infinity happens to be the same, and so the V infinity that they get is 52.50. So use this. So this is blank. So use these values to find V infinity minus VT. Very straightforward. You just take this minus that, and then you find the ln of this. Okay, and so use this to actually plot this, and you get the negative k, and you can get the rate constant and also the half-life. So very straightforward for today's experiment. In fact, for the two experiments, experiment 2 and 3. So again, the objective, results and discussion. Why is this a first order reaction? Conclusion, references used, and all this both experiment are due on the 29th. And please submit them both in one email. Okay, so that's it for today's experiment. So until next week, you take care. Thank you, and Assalamualaikum warahmatullahi wabarakatuh.